This last video is about Lawn Chair Larry. And Lawn Chair Larry is one of the few Darwin Award winners who actually won a Darwin Award and lived to tell about it. So the Darwin Awards listed up here says the Darwin Awards salute the improvement of the human genome by honoring those who accidentally remove themselves from it. And they do it by some crazy, strange way. That they say it improves the human genome in the end. So Lawn Chair Larry did something so crazy he actually won a Darwin Award even though he lived to tell about it. So what Larry did was he decided he really wanted to fly, but he couldn't be a pilot because he had bad eyes. So he was sitting back in his lawn chair, his comfortable Sears lawn chair one day in his backyard, and dreamed up this idea how he was going to attach some balloons to it and float up into the air nicely. So his plan was to float lazily up to 30 feet over his yard and watch. So what he did, he got 45 weather balloons, filled them up with helium, attached them to his Sears lawn chair, strapped in some Miller Lite and a pellet gun so that he could pop the balloons and get back down when he wanted. And what actually happened was they let go of the lawn chair, and instead of floating lazily up to the 30 feet like he planned, he streaked into the LA sky as if shot from a cannon, pulled by the lift of, it says 42, it was actually 45 helium balloons. Didn't level off at 100 feet or 1,000 feet. After climbing and climbing, he leveled off at 16,000 feet. All right. Where he was spotted by TWA pilots, it's an old airline, on their flight path into Los Angeles airport. And he stayed up there for 14 hours. He had his sandwiches, but he was a little scared at that height, at that altitude, to go ahead and shoot out his balloons, but eventually he got the nerve and shot out the balloons. Came down, landed in some power wires. The reporter asks, why did you do it? And his answer was, a man can't just sit around. So anyways, this last paragraph's funny. The Federal Aviation Administration was not amused. Safety Inspector Neil Savoy said, we know he broke some part of the Federal Aviation Act, and as soon as we decide which part it is, a charge will be filed. So anyways, Larry, interesting subject. And in class, I'm going to show you an actual newscast of that Lawn Chair Larry's flight. So what happened to Larry? Why did he shoot up into the sky like he did? Well, it all has to do with buoyancy. That's why I'm talking about Larry. So let's look at, this is a buoyancy example. And first what you want to do is start with a free body diagram. And here's a balloon. Let's just do it on one balloon. We can multiply by 45 to get the total force. We're going to have a buoyancy force, and then we're going to have a weight. Okay. And as long as that buoyancy force overcomes that weight, you're going to get a net upward force. And if for the whole 45 balloons, your net upward force is greater than whatever that chair and beer and all that stuff weighs, he's going to go up. Okay, so looked up weather balloons, and the weight of one balloon is about 0.4 pounds. Okay, that doesn't include the whole weight though. That's just of the rubber. The total weight of that balloon also includes the helium that's inside, so 0.4 pounds plus the weight of the helium, which is gamma for the helium, times the volume. Okay. The buoyancy force, that's what we're just studying. The buoyancy force is going to be the gamma, not of the helium, but of the air, because that's the fluid that's displaced, times that same volume. Okay, and the volume of a sphere, as you know, all right, sphere is 4/3 pi r cubed. Okay. So our net force, taking both these forces into account, is gamma of our air, buoyancy force, times the volume, minus that weight, gamma of the helium, times the volume, minus the balloon weight for one balloon. And so pull that volume out, factor it out, 4/3 pi r cubed times gamma for the air minus gamma for the helium, and then minus our 0.4 pounds. Okay, so if Larry had just filled these balloons to 4 feet in diameter, so 2 feet radius, if I calculate out this net force and multiply it by 45, this is for 45 balloons, that wouldn't have even lifted him off the ground. He probably weighs more than 80, especially with his Miller Lite in there. But these are latex balloons. They're very, very stretchy. In fact, I looked online, and one that was normally 8 feet in diameter, I think, stretched to 20 feet in diameter. So let's say Larry filled it up a little bit more. Well, if you fill it up to 5 foot in diameter, which isn't much stretching, now you've got an upward net force of 173 pounds. To 6 feet in diameter, it's 300 pounds, 500 for 7 feet, and so on. So if he, like, say, weighed 200 pounds and he filled each of those balloons to 7 feet in diameter, which it looks like from the pictures, he did at least that much, he's going to have a really big net force pulling him up. So that's basically what happened. From the picture, it looks to me like they were around 8 feet. Okay, using F equals ma for that, just in the y direction. His initial acceleration for 8 feet in diameter would be approximately 66 feet per second squared, or about 2 Gs. Pretty fast. Okay. So he's going to shoot up into the air pretty fast. Of course, this is initially that you have buoyancy and weight. You would also have drag once you start moving. So that would have to be taken into account if you're actually trying to figure out his total velocity as he went up. Eventually he leveled out at that 16,000 feet. So you might wonder, why did he level out? Well, think about what's going on with these gammas. As you go up, gamma for the helium might change a little as the balloon gets bigger. You're going to have a lower pressure, so a bit lower helium. Gamma for the air, as you go up, 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 you get to 16,000 feet, you're actually going to have a much lower gamma for your air. So this difference is going to eventually get smaller, and once you end up with a 0 net force overall, he's going to level off. Wasn't at 30 feet though, above his backyard. It was a little bit higher. So anyways, that's Larry's story, and that's buoyancy for you. So go ahead and you can finish the quiz now.